Hello, this is Mrs. Huntley. We are in Module 4, Lesson 21, Some Facts About Graphs of Linear Equations in Two Variables. You should be on page number 86, and your essential question for this lesson is how do you find the equation of a line if it is not passing through the y-axis at integer coordinates? If I sound a little bit frustrated, it's because I've recorded this lesson 3 times now, and one thing or another keeps happening to where the recording gets ruined and I start over. So hopefully this time it's all going to work, or you might hear me screaming on the video in frustration, not at anyone in particular. So let's look at example number 1. All of a sudden, the last couple of lessons that we've been looking at, we've learned how to graph equations. We've learned how to look at graphs and write the equation. And our friend is slope-intercept form, y equals mx plus b, where we just have to substitute in our slope and our y-intercept. But now we're looking at a line where the y-intercept is all of a sudden not crossing at an integer. It's crossing in between 2 and 3. And it looks like it might be 2.5. Not exactly sure. And maybe we could do some sort of a guess and check process to see if it is 2.5. But what if it's not 2.5? We might spend a whole lot of time guessing and checking different fractional numbers and not arriving at an exact answer. So I propose that there is a more efficient method of solving this particular problem. And what I would suggest doing is that we figure out what we know and see if we can solve for what we don't know. So if you notice, I made some points on our graph of where our line is crossing at integer coordinates. And from those coordinates, we could determine the slope. So we are rising 2, and we are running 7. So our slope we've determined is 2/7. And let's see, what else do we know? We can figure out some integer coordinates. We know that the line is crossing at -2, +2. Our x is -2, and then we go up to +2. So we've got -2, +2, and this is our x, and this is our y. So if we think about our equation, y equals mx plus b, we have almost all the information that we need. So let's go ahead and substitute in what we know and see if we can solve for what we don't know. So y is 2, m is 2/7. Oops. X is -2, and the b is the only thing that we do not know. So let's grab our calculators and take 2/7 times 2, or if you want to try to do it in your head, we are multiplying fractions, so we multiply our numerators together. 2 times -2 is going to be a -4. 7 times 1 is going to be 7 plus b. We want to see if we can isolate the b, because we're trying to solve for the y-intercept and find out where this line is crossing the y-axis. So the opposite of -4/7 is going to be a +4/7. So if I add 4/7 to one side of the equation, I've got to do the same thing to the other side of the equation. These end up zeroing out, and I'm left with this b by itself on the right side and 2 and 4/7 on the left side. Now 2 and 4/7, that's almost, it's a little bit greater actually than 2.5. 2 and 3.5/7 would be 2.5 exactly. But 2 and 4/7 is a little bit greater. So if I look at my graph, that's logical sense that it could be 2 and 4/7. So if I'm rewriting the equation in two variables, y equals my slope, I said was 2/7, plus my y-intercept I solved, and it was 2 4/7. So I am saying that the equation of this line would be y equals 2/7 x plus 2 4/7. What were the steps that I went through? I determined the slope of the line, then I named the coordinates of one of the points where the line is crossing at integer coordinates. I substituted in the information that I knew into the equation y equals mx plus b. I solved for what I didn't know, and then I rewrote the equation in two variables. So y equals 2/7 x plus 2 4/7. So if you need to pause the video to take the notes down, go ahead and do that. I am going to move on to the example on the next page. So page 87, we're looking at example 2. It's the same type of situation. We're going to take it step by step. So first, I need to determine the slope of the line. Find some places where it's crossing at integers. I'm going down 1, 2, 3, and then over 1, 2, 3, 4, 5. So my slope is a negative 3/5. My next step, determine one of the sets of integer coordinates. I'm just going to go with this one here, and that's a -1, +4. That's my x, that's my y. My third step, substitute what I know into the equation y equals mx plus b. So I'm going to rewrite my equation. Y is 4. M is -3/5. X is -1. And then b is what I do not know. Now I'm going to solve and see if I can figure out what the b is. I should probably grab my calculator. Left side, I don't need to do any math. It's still going to be 4. Now we have a negative times a negative, so I know I'm going to be a positive. 3/5 times 1, anything times 1 is going to be the same number, so it's going to be a positive 3/5 plus b. I need to isolate the b or get the b all by itself. Whatever I do to one side of the equation, I have to do to the other. So I'm going to subtract 3/5 from the right side. I've got to subtract 3/5 from the left side. Again, grab your calculator here because this even messes with my head. 4 minus 3/5. I could at this point change the 4 into a fraction where it would have 5 as my denominator. But if you're using your calculator, it should come out to 3 2/5. So if I'm rewriting the equation now in y equals mx plus b format, I should have y equals, my slope I said was -3/5 plus my y-intercept at 3 2/5. Now let me take a look at the equation and make sure that it makes sense, that it would be 3 2/5. Here's 3, here's 4, and it's coming in a little bit less than halfway. So yes, that makes sense. I want to make sure that my answer is logical. Now the next part of it says transform the equation so that it's written in standard form. Standard form is your ax plus by equals c. I know some of you really enjoy this part of the number puzzle, and that's fine. Those of you that enjoy it, we'll do this example together, but then from here on out, I'm not going to do these examples. Putting it into standard form, what I'm most concerned about is that you can write an equation in slope-intercept form. So the easiest way to do this, I need to convert this y-intercept into an improper fraction. So if I do that, I have y equals -3/5 x plus 3 times 5 is 15, plus 2, that would be 17/5. I need to get my x term to the left side of the equal sign. So I'm going to add 3/5 x to the right side, add 3/5 x to the left, and I've got 3/5 x plus y equals 17/5. In standard form, the number that is in front of the x cannot be a fraction. It's got to be an integer. So I'm going to multiply through by a 5. 5 times 3/5 is 3. So I've got 3x. 5 times y is 5y. 5 times 17/5 is going to be 17. So in standard form, the equation would be 3x plus 5y equals 17. In slope-intercept form, the equation is y equals negative 3/5 x plus 3 2/5. Again, this is what I'm concerned with. If you didn't get to the standard form, or if when I started talking about standard form, you were like, what is she saying? That's okay. Don't worry about it. Next example. Example number 3. You should be on page 88 of your module. Let me get to page 88 of my module. And the y-axis is not even shown. Oh my goodness, what do? I'm going to attack this problem the same way that I attack the other problems. Find some integer coordinates, determine the slope. I'm going up 1, 2, 3, 4, 5. Right 1. So my slope is 5 over 1, or just 5. Name one of the sets of integer coordinates. I'm going to take the first one that I see, just because it's easy, and that's the first one I see. So I'm at 12. Being that my x is counting by ones, this is 9, 10, 11, 12. I'm going to assume that my y is as well. So as I'm going up, I'm going to say this is 1, this is 2. So I'm going to assume that that's a 2. My equation, y equals mx plus b. Plug in what I know. Y is 2. Slope is 5. X is 12. I don't know b. Use my calculator. 2 equals 5 times 12 is 60 plus b. I want my b all by itself, so I'm going to subtract 60 from the right side of the equation. Whatever I do to the right side, I've got to do to the left. 2 minus 60 is negative 58. So b equals negative 58. I can write that in my equation. Y equals, slope is 5, minus 58. If you have any questions, please make sure that you're making a note of them and that you're writing them on a sticky note or you're writing them in the margin so that you can ask them in class tomorrow. I wrote the equation up there, but I should have written it down here. So y equals 5x minus 58. Again, I'm using the information that I know, plugging it in or substituting into slope-intercept form and solving for what I do not know. Next example. We are back to where, yay, it's passing us some integer coordinates. So my v here is 0. My slope is 1 over 3. So writing the equation for this line, y equals 1/3 x plus 0. Technically, when your y-intercept is 0, you don't have to write it as long as you have a slope. So I could have just written y equals 1/3 x. That would have been acceptable as well. This discussion that's at the bottom of the page, the concept development, what Eureka is asking us to do is kind of talk about point slope form of a linear equation, which is another way of writing linear equations. And it's something that you're going to be master when you're in algebra. So it's not something that I feel we need to master at this point. 8th grade standard talks more about slope-intercept form and writing the equation of a line. So I want you to focus on mastering how to write the equation of a line in slope-intercept form and not so much worrying about the other forms in the equation at this point in time. Let's look at a couple of other examples. I would like you, let me skip a page. Okay, what is point slope, or what is slope-intercept form? Right now, I would like you to write y equals mx plus b. If you don't already have this memorized, we're on page 90. If you don't already have this memorized, it should be m is your slope, b is your y-intercept, y is a coordinate or a variable, and x is your x coordinate and your other variable. X is your independent variable, y is your dependent variable, which means how much x, or how much your y changes depends on how much x changes. What information do you have to know? I need to know the slope and either the y-intercept, or I need to know a set of interior coordinates. Either way, I will be able to solve for what I don't know. So I'm going to end the lesson here, and we are going to do the exercises together in class tomorrow. What I would like you to do, however, if you have the opportunity, is to write your summary on page 92. The things that we went over in this lesson, you need to have 2 points. If you have 2 points, you can determine the slope. If you have a grid, you can count your rise over your run to determine your slope. If you don't have a grid, remember we have several methods that we could use to determine slope. We can use either the Larkin or L method, or you could use the slope formula to determine the slope between 2 points. Once you know the slope and you have one set of integer coordinates, you can plug in the information that you know into slope-intercept form and solve for the y-intercept. So hopefully that will give you an idea of how to write your summary. And I will see you in class tomorrow. I hope you have a good night.